And boom! Hello! Okay. Hello? Hello. I am back. codingmatheus live here again. I am also trying a couple of new things today. And I am starting to... Hey, Damien! Oh, I love this Racho Wiggle. God, I really gotta catch up with whatever's been going on Twitch. All right, let me, first of all, two things I did very wrong last time, which I'm correcting right now, is one, the chat is working! What do you know, right? I know, right? Takes a data scientist to fix a chat. And the second thing is... wait, I'm just making sure everything here is muted because I can hear some echo, and that's exactly what the second thing was. I could hear echo when I watched back a little bit, but it wasn't echo. It was because I had this little thing here, right here on my desk, but I had the volume on up. So yeah, what do you know? My condenser is a super condenser, and picked up everything. So, if there's any tiny little echo, please let me know. It's funny because I can still hear myself. I don't know why. But it's... Oh, because I got the computer sound. Okay, fine. So, I'm probably not going to be using this anyway. But I just want to make sure that there is no echo if I put them down. Except for whenever I want to hear some sounds, maybe. If we're going to hear stuff together. Two questions I have right now. One, can you hear computer sound? As in, can you hear the game's audio? There should be a very light, kind of very relaxing type of music happening from the game. I don't think you can, because I don't see the meters going up and down. I wonder. Let me see if I can fix that. Yeah, okay, good. Oh, you know why? Thanks for letting me know. Wait, let me think. How can I fix this? So, yeah, it should be coming from here. Except that, oh, I don't know. I mean, to be honest, it's just like a little piano music thing. So it doesn't terribly matter. Let me see. Right. Yeah, it doesn't terribly matter. Ooh! Cuckoo! Hey, first time chatter. I wonder who you may be. Olivier Lep? Huh? Monsieur Le Plus! Where have you been? I miss you, man. You went around the world now doing something? I don't know what. I guess that's what you do on vacation, right? You just do stuff. So I hope you're having the time of your life, wherever you may be, whatever you are doing. However much you are resting. I'm not sure joining my Twitch counts as resting for you. But fear not, because if you just want a little bit of distraction before you go off to do something else, I am not going to be talking about Australia. That's it. I knew. You're back from Australia. Oh my God, a whole month and only a few hours ago? Aren't you sleepy? Or maybe that's the point, right? You can't sleep now, so you join this. Why not? You figure I will put you to sleep. Olivier, you should know better than this. Right, I can't fix that sound for the computer thing. So you're going to be without the nice little piano music. Oh, but that's not nice, is it? That is not nice. I know why. Oh, wait. I think I know why. Or maybe not. Oh, there you are. Can you hear now? Can you hear now? David, you know why I like you? Because you put it like it is. You say it like it is. Okay, oh God. You know what I hate though is that I get to hear myself if I do this. I'll figure out another way eventually to do this. But I know how I'm going to do this. Dun, 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 dun. There. I can't hear anything right now. So if anything's dodgy, you guys let me know. All right. So, wow, welcome back, Olivier. Good to know you're back from Australia. I take it that it was amazing. My question is, did you run into any snakes? Because that's why I haven't been to Australia yet. I do not want to go to Australia and run into snakes because it's snake country. Yes, please like and subscribe. Drop. I didn't say that. Damien did on the chat. So yeah, I mean that's the one reason why I have not gone to Australia yet, because I really, really want to go. But every single Australian person I talk to, they go like, I was like, is it a myth or is Australia full of snakes? They go, no, it's not like that. Of course not like that. Yeah, but like, for example, when I was a kid, yeah, I went to the toilet and there was this snake and I kind of tossed it. I was like, what? No, thank you. So yeah, hopefully didn't run into any snakes. And hopefully 24-hour flight watching from my bed, but won't stay long. Don't worry, you don't need to stay long. I know a few snakes in the UK. You don't need to stay long, Monsieur Le Pleu. I really appreciate just coming and saying hello anyway. I just see it also as an opportunity to catch up, you know, with the billion people I don't catch up with. So yeah, always, you know, just come in, say hello, drop, it's fine. So what are we doing here? Oh, I forgot to crop this thing. Okay, various things are gonna come up during the stream. The first thing is that somebody actually asked me this on DM today is, okay, you're starting at night, when do you actually end? I don't know. That's why I'm not putting at finish time. You guys can go, come back, or go, never come back. I'll probably be here talking to myself. Somebody once said that if it's me and a plant in the room, then I can still talk for hours with the plant. So for me, really, the threshold here is when I kind of had enough. When I'm sleepy, I need to go to bed because unfortunately we got work because it is Tuesday only. So you know what, Damien? I could actually. I don't think it will be that much of a challenge for me streaming for 24 hours. Like when in the last episode, when I stopped, it was like an addiction. I immediately wanted to go back into it. All I needed was like a 10-minute break, but then I had to go to bed anyway. And I was already yawning, so I was already tired. But I went to bed thinking, oh, I want more. And yeah, I don't know. I just feel like doing this every day. I feel like if this was my job, fantastic. I could do this all the time, every day. I just like live more. I don't know. It's fun. It's authentic. You know, nobody's, you know, hyper editing anything here. If I say crap, I say crap, and you get the real crap. If I say good things, then they're good things. If I'm not saying good things, then, you know, chat can always guide me. And we can make it all super productive and fun for everybody. You know, I don't know. I just love life. I have cameras on all the time. Just live my life like that. Live. God, that sounds like an episode of Black Mirror. Right. So, welcome anybody who's joining here. What is this all about? What is Coding Matheus Life? So, I'm Coding Matheus everywhere online. I teach tech. More specifically, I teach artificial intelligence, machine learning, generative AI. Have you ever heard of that? But not just generative AI and the hype stuff, but literally, you know, all the science behind it, which is something that I completely fell in love with. To be honest, completely fell in love with it like about last year. And then I specialized in different things in the past in my career, like distributed architectures, enterprise systems, microservices architecture became like my thing for many years. Then serverless. And then even like internally, I work for AWS, by the way, full disclaimer, but opinions are my own. And this is not an AWS channel, meaning we can talk about anything. But, you know, within AWS, I specialize within serverless for a while. And how you know I'm not an LM? Because have you tried the video ones, the generative AI videos? I mean, to be fair, they're getting there, but they wouldn't get this real, not with this many gray hairs. But you know, and then I start really thinking about AI and going, well, I know some stuff about it. I've come across it in my career before in a few different things, and the math is always something very attractive to me. I'm very much a nerd. Like I actually bought like GCSE books on math just to like as puzzle books just for me to do every now and then. terrible. I know, very geeky, very nerdy. But I loved math. I started as a junior video game programmer. And as any game programmer will know, matrices, all that kind of stuff. So yeah, I've always been attracted to the kind of more deeper side of things that data science offers, which web development doesn't really. It's very abstracted. Web development still got loads of challenges, but that's kind of what I did after my game programming days, seriously, professionally anyway, because then I continued that on the side. But and then yeah, last year I just thought AI/ML is now catapulting into a whole new era. That's just before generative AI, but that's a whole other story. But generative AI has been happening for a long time. It's just not at this scale, not in this way, not with foundation models, right? And that's a whole story in itself of why we catapulted ourselves forward so much. Spoiler alert, attention's all you need, 2017 paper. But yeah, and then this kind of became my true thing that I've been going really deep on, and yeah, kind of been retraining myself, if that's a word even, pun intended, as a data scientist. And yes, web dev does rock. I do love web dev. I think it's just came to a point where I've got 22 years of career now. It just came to a point where I guess it's like done that, been there, got the t-shirt, what's next? And it just had this beautiful kind of, I think perfect harmony with the explosion of AI. And I was like, yeah, you know what? This is making sense. Boosh. And here I am. But as we know, as you know, Olivier, anyway, it can very much play a part into web development now because AI is democratized effectively. And what do I do here? So in this channel, I wanted to do something different and something light as well. And because I am multicasting right now, full disclaimer, to YouTube and Facebook. I don't think Facebook is working, to be honest. I don't know. Let me refresh the page. And I'm only doing Facebook because it was easy, because it was there on the option. So I was like, why not? But I got zero everything on Facebook. No one cares about me. And I have been on Facebook for so long anyway. So yeah, I don't think Facebook's working. But anyway, I'm multicasting. But my main thing here is Twitch, which I used to do when I used to do gaming content, and I haven't done in many years now. And Twitch moved on a lot, which is why I'm relearning all this stuff. Yeah, so I wanted to play a game. So the concept here is that I'm gonna play geeky games, and these geeky games are always educational about tech, even if maybe one or another one may end up being loosely related to tech. Like there is one which is investigating this AI company which is taking over the world, like Skynet, Terminator type of thing, which is fun, and gets us talking about AI. But I may play that one later. But I thought I would start with Wild True Learn, because Wild True Learn is a game that not many people know, but it's a game that teaches artificial intelligence, machine learning. It's really cool. But it's a game. It's a puzzle game. But as you can see here, if you haven't seen Wild True Learn, it does have different links and things like education, credits, whatever. So if you click here, it has links to like Wikipedia, to Kaggle, to different stuff. Also their own stuff, which I think is pretty clever actually. They created a whole game to kind of advertise their other, channels and things like video courses, which is brilliant. So kudos to them. And I guess along the way we may explore all this stuff, going to them, read them together, whatever. So whatever you guys feel like. Lab coats incoming. Yes, I am kind of lacking costumes now, to be honest. I accumulated so many costumes in 2022 mostly. Like when I became a DA in AWS, I was with AWS before as a solution architect, but then I moved sideways to become a DA. And then I just went on a costume collection frenzy because I just had all these crazy ideas. I don't know, I've become a little bit more tamed recently. I think I do need to refresh my costume closet. Having said that, if you saw me at the London Summit, maybe you wouldn't call me tame. I'm going to an AI event that AWS are doing at Media City tomorrow. Wow, AWS Gen AI Unicorn Party, apparently. And you know what? That sounds vaguely familiar, and I'm trying to remember why. I think I think I know why. I think I put someone in touch internally to go to the event because they needed support or speakers or something. I don't know, something. I don't know. It's vaguely familiar. Awesome. Let me know how it goes. Would love to know. I'm very interested because I am doing a lot of the AI content now, the machine learning content, in events and conferences and stuff. But to be honest, I'm kind of like getting started. Well, you know, Damien, anyway. I'm kind of just getting started still. No matter how much stuff I do, it still feels like I'm just getting started. So I'm it's still in my to do to scavenge what is it that we're doing as AWS, what are all the events, and then figure out how I can help or support or be part of it. uh Nick, this brings more and more bells. Okay, yeah, just tell me how it goes. I'll probably look it up later anyway, or post about it anyway. And then I can check it out. That's awesome. And I love that you're getting to AI and all that. I feel like that there is a little bit of eye rolling that goes on. I was literally talking to a group of people after a talk I did last week or the week before in Nottingham. I don't remember when. Lost in time now. And kind of had an impromptu focus group with the people there, after the event. There were like about 20, like in a circle, and they were all asking questions. It was amazing. So I kind of took an opportunity to ask a question myself, and I said, hey, what if what's going on with the whole AI thing? Because there were a lot of devs there, not data scientists and stuff. I said, are you guys kind of tired of hearing about it before we even got started, with this whole AI revolution? And you know what? It was quite positive. At least the feedback I got from them was, from that group, was that no, it's interesting, it's good, we're curious, but one, we cannot do it in our jobs yet, so that's a bit frustrating, and that's why when we go to events, we don't necessarily gravitate to the AI talks or machine learning talks because, there are other talks that exactly to do with what we're doing right now in our work. So that makes sense. And the other thing is that, yes, there is a little bit of feeling like Gen AI or whatever is being pushed, down everyone's throats because it's like the revolution everywhere. I'm not talking even about AWS specifically or Microsoft or anybody. It's kind of a general feeling that Gen AI came in, ChatGPT came in and took over. And developers are like, what's going on? It's already got a lot to learn and catch up with. So I feel there's a little bit of that. But go for it, Monsieur Le Plus. Yes, have a good night. Well-deserved night after coming back from Australia. Sleep well, and sweet dreams. Don't dream of snakes. But, I feel like, at least where I come from with my content, and what I try to do is teach the science, teach data science, teach machine learning. And then, of course, you got all these abstractions on top, which then help reach people like beginners, or maybe if they're not even that beginners, they know something about data science or science, or even like data engineering, which already helps already a lot of that theory, to come on board this whole generative AI train. And not just generative AI, by the way, AI, right? Machine learning in general, because they make things more accessible. Like you just mentioned, Damien, Bedrock, and Amazon Q, or ChatGPT, indeed, or even like Claude on iOS now. You can get on your mobile phone as well. Like, so much stuff that now makes it so accessible, so concrete, and so real for developers. And I think easy to get on board, easy to see the value of it, not just business value, but like developer value. And then easy to get that kind of fuzzy feeling that, oh, I feel good about this. I know this stuff is not that scary, which I think is quite important as well as motivation. This is what's appealing about Bedrock, though. I feel like SageMaker always had an element of data science about it. It does. Whereas Bedrock feels a bit more accessible. Guess I'll find out tomorrow. Yeah, well, there is something that, a proposition that we're putting out, that we are talking in various different corners as AWS, about the generative AI stack. So you're absolutely right, because SageMaker sits at the bottom of the stack, whereas Bedrock is like the middle of the stack, whereas Amazon Q is like top of the stack, right? So it's just different levels of abstraction. SageMaker is for you to train your models, for you to do stuff that I'm gonna be talking about here today, like decision trees and whatnot. When you want to get into the meat and potatoes of it. Apparently, that's a German expression. I love that expression. It's so weird. It doesn't feel right saying it, but which is the core of machine learning. And then you're actually going to apply data science as an initiative. You're going to be an active part of this. Whereas with Bedrock, you are an active part of it, but on a different level, on a different abstraction level, right? Much like you didn't code PHP as a framework, right? You just, I don't know why I picked PHP. I'm trying to be neutral. Sorry, PHP developers, but ASP.MVC, or Django or Flask or whatever. Flask, I mean. So, you didn't code those. You just got the latest updates and you got the latest abstractions. And then you go with a React. Let's be a little bit more, I guess, neutral. You just use it, or Next.js, whatever. So same thing, Bedrock gives you that level of abstraction so you can get productive, can get going. You still gotta learn the stuff, how to use it, but you are like on this level. And if that's what you do, and that's as much as you need, or that's as much as you want, that is absolutely fine, because it's gonna take you to all those places that you need to go in the modern age of development, whereas you can go deeper if you want, and then go into different ways. Like I said, I start specializing in it, and my God, there's so much to learn, which is why I love it so much, right? If some of you know me, I speak Japanese. I love Japanese. I'm obsessed with Japanese because it's an infinite learning curve. That language is like, it's the gift that keeps on giving, right? And machine learning is much of the same. Data science is much of the same. So, hello, welcome, Ox. I keep trying to say these usernames, and sometimes it gets me into trouble, but I always try. Why not? Oxgbet. I mean, nothing dodgy about yours, but it's just that I guess sometimes you can not think of how these things are gonna sound when you start pronouncing things that are not necessarily words. But this one's good. Welcome, Oxgbet. So I'm guessing you're on Twitch. Oh, look. Some people actually were chatting on YouTube. I think Facebook's not working, but anyway. So I did put it out there that we're going to be doing decision trees today. And the reason for that is because if you were in the last episode, if you joined me at any point, you would have seen that what I'm doing, like I mentioned about 10 minutes ago, I think, because I'm waffling on now. I'm going to be playing Wild to Learn. This is a game that teaches machine learning. And where we stopped last time was in a level that started going into decision trees. So I thought, well, we're going to go into it. So I think I'm going to be teaching it. So let me load the game so we see where we stopped last time. So if you haven't seen the game before, you start down here and there is a little story going on where we're a programmer coding late at night. And then we get a bug and we're stuck with this bug. And then the cat, when we go get coffee, the cat goes to the computer and actually solves the bug. And then we're like, what the hell? My cat can debug. So that's the story. And then he goes, okay, I need to understand my cat because clearly, he knows stuff. And it's a silly story, but it's a cool premise. And then we go into this little story where he goes on Cat Overflow, I think is the name, right? Which is obviously a pun with Stack Overflow. And then he asks a question, how can I create an AI that understands cats? And then it goes, whoa, slow down. Let's take step by step until you get to the point where you can actually understand your cat. So that's what you're seeing up here, cat speech recognition system. We are 16% progression into that, because we're accumulating that knowledge where eventually we're going to be able to build a system. And recognizing cat on pictures is where we're kind of starting. So it's like, how can we recognize that a picture is of a dog or a cat? We're not ready for it yet, for that kind of thing, but we are 85% armed with knowledge because we're progressing through this tree. And these first levels are tutorials, I guess. And there is here a little classification of purple and green. Almost machine learning because it's very much the basics, and now basic machine learning, which are the green levels, I think. Yeah, because see, this is purple again. Not sure what this is. Haven't clicked on that yet. So what have we learned so far? Let's see. Damien, do you remember? Were you here? You were here, right? I don't know if you were here for the whole thing, But we were talking about expert systems, right? Sorry, I'm just catching up with chat. Amazon Beanstalk at the top. I have to say, I have to say, I do. And now I just saw the rubber duck comment. I do work for AWS, but Beanstalk, many people still use Beanstalk, so it hasn't been turned off. But I don't recommend you start with Beanstalk these days, right? Don't do that to yourself. So I fully get that joke because I think you are of the same opinion. Yeah, feels like SageMaker Bedrock have a similar relationship to CloudFormation CDK. Yeah. So for those that don't know, like CloudFormation is IAC, like infrastructure as code, and it's the most raw form of infrastructure as code on AWS, Amazon Web Services, for the Azure and GCP and Alibaba people. So like equivalent Azure would be like ARM, resource and ARM and all that. So yeah, it is similar, and CDK is like the abstraction of that. So use Python or TypeScript to generate these things behind the scenes, so you don't have to do the raw thing. Yeah, so similar thing. How drunk is this programmer by the point he's getting coding advice from his cat? Has he not tried ChatGPT? I feel like ChatGPT is a pun that would have been in the game had he made this game after ChatGPT came out, but this game is actually kind of old. I think it is 2022 if I'm not mistaken, but like beginning 2022, so before the generative AI, revolution. Yes, friends don't let friends use Beanstalk. I agree with that. If you got legacy, that's fine, But for example, why wouldn't you use Beanstalk? You cannot even use like Python 3.12 with it, right? So it's actually, I was reading a good article on updating your Python and all that, and reasons why you wouldn't right away from a professional that runs production systems. And one of the things he mentions on the article is, I'll share that over the weekend actually, is because they use Beanstalk, and so they can't really upgrade. They have to be careful. Yeah. Beanstalk is a lot. Anyway, what have we learned so far? So we started learning about expert systems. What are expert systems? Expert systems is, I don't know, maybe I can even like replay the level. Can I? Yeah. Oh, right. There. It gives us the story again if I click on the level. That's good. So we can do a little bit of a review. So we go on Cat Overflow and we say, oh, not sure what we're doing here. They said, take it easy. Before you get to this whole machine learning advanced stuff, start learning first about data, and data classification really is what it comes down to. So it tells us to use this expert system, which I've already done. So it's already done here. And the way it works is we got the data from our camera, and we're abstracting away the concept of how we're classifying whether we have those photos have a cat or they don't have a cat, right? So we're not gonna dive deep into how we know this, because this is the advanced stuff, right? But for now, we're gonna know, okay, somebody already classified this. We know that we got red pictures, and red pictures are photos with cat. We know we got blue pictures. Those pictures are photos with no cat on them. And we just need to make sure they go to the right buckets. So we are classifying these pictures, right? So if you heard of classification algorithms, that's what they're about. Is it this? Is it that, right? So we classify. This is a classification algorithm, albeit a very simple one. And the algorithm that we're using here is an expert system. An expert system is a really early form of machine learning, because it's effectively an if and an else, right? So in this case, we got an expert system, which is, if it's red, we got socket here, we're gonna go there to this bucket, photos with cat. Else, if it's not red, then we're gonna go here. So we're gonna sort out all the blues this way, all the reds this way. These things here is occupancy. So that just means like the accurate, how many data items we need to process. So for us to clear this level, we need to process at least 8 pictures that has a picture of a cat, and we have to process at least 8 pictures that have no cats on them. So not the full data set is necessary, but we have a goal of 100% accuracy, and 100% accuracy here as well, meaning we cannot have any garbage in here. They all must be red, they all must be blue. Sure, easy enough, right? Connect red here, else there, if and else, fine, test run, and then you see red's going there, blue going here. So that's the basic principle, right? Especially with expert systems, which all about that. Case statements, yes. Well, switch statements were advanced at the time when this thing was popular. And there you go. We finished the level, and then we can move on. In which case, I'm just gonna get out because we've already done this. Do I have to do all this again? So I guess like kind of a beginning and end of a level. There's like the story at the beginning and the story at the end. Okay, cool. Now, of course, it gets a little bit more complicated than that, because what if you actually have loads of different pictures, green, red, blue, yellow, but you must only have 100% accuracy on that one, 100% accuracy in that one. Maybe we can tolerate some inaccuracy in the other one. How do you split these things? Then you start using multiple expert systems, right? Because it's the only way you can do it. If else, if else, if else. And pretty much this is the way AI was done early on. So what you will have is a data engineer. So the data engineer was the most important thing, and still is, in my opinion. Not the most important thing. Okay, data engineers are super important, but so are developers, so are DevOps, so are data scientists. These data engineer, this data expert, what they will do is have a bunch of meetings and go, with all this data, let me know what's important here. What are the important things that I can tell that this picture is a cat, this picture is a dog. And then it was just going, that person was just going to create a bunch of if analysis that reflected the expertise that they accumulated. That's why it's called expert systems. But it was still human driven. The algorithm was a human taking stuff from their brain and putting into if analysis. They could have written in English, they could have written in Japanese, they could have been an essay. It just turned out that they mapped those ideas and that knowledge and that expertise in if analysis. That's an expert system, plain and simple. But now we actually start with the basic of machine learning, supposedly, which is finding a cat in the picture. Okay, let's see where we are here. So I'll go on Cat Overflow, my character anyway. And by the way, it's codingmatheus because it didn't fit codingmatheus character limits. Hey, is there any way to detect the cat without using expert systems? It works for text, but with pictures, not so much. Furthermore, that cat just won't sit still. That it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try Sift. This little dev is way more effective with pictures. Also works nicely when paired with other algorithms. Okay, that is a lot, because trust me, decision trees is already a lot. And I'm thinking we're gonna talk about decision trees today, but you know, if I'm gonna approach this as a lesson, if you actually want to learn about decision trees, there's a lot to talk about. Or you can use nails or glue or something. Come on, it's just a cat, it won't fight you back. Not true. And actually I went off on a tangent last episode on how that is not true because of a cat that did not love me back once. IJK, please. What's IJK? I just know. Is that what IJK is? God, I'm not down with the lingo, am I? Please don't use anything I mention on an actual cat. Okay. So I actually got this going before I turned off the stream last time. And so let me walk you through what's happening here. So now we got the camera feed. We still got two output buckets here. We got red and green, and then we got green and blue. And here we need to process 12 data items, and then 12 data items here as well. Both need 100% accuracy. So what we're gonna do? Well, instead of using the expert system, which is just a raw if and else, we're gonna use a decision tree. Let's see what this decision tree widget, as per the game, does. So we click on the info button and it says decision tree color. So in the game, this node compares output parameters, the sockets. Sockets are these things that we connect, right? With an element color. If the element color is equal to only one socket color, the element moves to the socket. Okay, so if it's red, it's gonna go to red. If an element's color satisfies both conditions, or none of them, it goes to a random socket. Let's unpack. So if it's red, it's always gonna go there. If it's green, it's then it satisfies none of them, so it's gonna go random, either here or there, right? If it's blue, it satisfies one of them, so you always go here. Does that make sense? Hope so. In the real world, and this is where we have so much to talk about. Decision tree is one of the basic machine learning algorithms, indeed. However, saying basic kinda gives the sense that it's outdated. It is not. Decision trees is still very, very useful as an algorithm for many things. One of the advantages, and this will make more sense as we dive deeper into it, is that it's highly explainable. So in the era of foundation models, which is kind of before this game was made, because like I said, I think this game came out beginning 2022, when foundation models were, of course, to those in the know, they already existed, but there wasn't this explosion of, everybody knows about foundation models. So I think, unless maybe it comes late in the game, I don't know. But anyway, so decision trees are highly explainable, meaning you can really know, you can even visualize if you use like matplotlib and stuff, things that I'll show you. You can know exactly how these decisions are being made, how the model is working out these decisions. It's like, how did it actually conclude that this is a cat or this is a dog? I can actually walk through that decision process. Whereas with foundation models, not so much. The level of explainability is much lower or nil, depending on what you're doing, depending on what model you're using, because we don't even know how these things sometimes come to the conclusions they do, which is a whole science in itself now. So yeah, this is really good, one, for when you want to be able to explain decisions made by the AI, right? Decision tree is great for that. Two, decision trees, they're very good for getting like a complex data set and making sense of it without you having to do much data cleaning, which is a huge plus. Hello, Wayward Thieved. Hello, welcome. Hello, sorry for bothering you. I want to offer promotion for your channel viewer. Thank you. If you're gonna give that for free, please go ahead and promote me. So, where was I? Yes, so decision trees, with decision trees, you don't need to do a lot of data cleaning. So sounds like heaven, right? Because a lot of the work that goes into data science is into data cleaning. What do I mean by data cleaning? Making sure you don't have garbage, because garbage in, garbage out with anything, right? Especially important with machine learning. Outliers, duplication, so deduping data, all that kind of stuff. So it takes many cycles and many things, many considerations to make sure your data is perfect. Never will be perfect, but it's great for what you need to do. And this is by use case, right? Use and case by case type of thing. So decision trees are great for that. Why? Because they work out what's the best feature, which means the attribute of that thing to use to make decisions on, right? That's crazy, but it's all mathematically backed as well, as we'll discover. So they're great for those two things. So no, they are not outdated. But yes, foundation models and all that can give a run for their money. But again, use cases and use cases, right? Also, don't forget, third reason here, highly explainable, less data cleaning, almost no data cleaning necessary, but also legacy systems. Because decision trees came way before foundation models and all that, there are lots of systems running on decision trees. So you're bound to find them for a very long time, much like you can still find COBOL systems, believe it or not. Things written in COBOL. Those people are rich now. Whoever kept on programming on COBOL made a career of that alone. Right, there are two links here, article and video. So this links to different stuff. So if I click on it, I can drag here so you guys can see. It links, in this one, it links to Wikipedia, so you can have a read about decision trees. video. I think I clicked on this last time. Yeah, it goes to this ad, and then it's yeah, it's an explainer video about decision trees, I guess, which I intend to do actually. So what did I do here? I connected the camera feed to my decision tree and then connected to these two things here, and want to see if this works. And it should work because, again, if it's red, it will always go here. If it's green, it doesn't fit any of these categories, so it will either go there or there. And we can have green on both, so that's fine. It's not going to break anything, and it's going to add up to my total. Great. And it's not going to decrease my accuracy because they both take green. Great. If it's blue, it will always go here, so this should work. Test run. Let's see. All right, so that worked. There is an element of the time spent, and there's an element of cost as well. It's kind of cool. We're running these things on cat cloud, again, fictitious cloud here for the game, and that means we are constantly thinking about costs as well, because every time we complete a job, we make money, but also there's running costs for us to process this, which is so important because with machine learning and AI in general, you always have to think about processing. It's a lot of processing. When people like me, when you hear people like me going on talks or content, whatever it may be, video, saying that it takes a lot of processing, machine learning, it's because it takes a lot of processing. And hopefully you discover here with me or in my other channels, if you want to watch on-demand videos, my YouTube or TikTok or Instagram, whatever, or if you're more of a reader, my blog on Medium, community.aws, and all kinds of other mediums, Dev2 soon. Then you will see, you will understand why it takes a lot of processing. And it starts with learning about decision trees, actually. Right, so I'm gonna save. And at this point, what I wanna do is actually tell you a little bit about the theory of how do I get out of here, right, like this, of decision trees, because I don't know where this is gonna go next. It's all purple and stuff. But, right, I actually have, a pad here. In fact, I'll tell you what I'm gonna do. I was actually preparing here I am preparing a notebook because I'm gonna be writing content about decision trees. I'm thinking, as part of this, so I can actually kind of run through the notebook to show you what I mean. And this is gonna be like content that it's so raw. I was literally working on this today, so raw. So forgive me for the rawness. Gosh, this cell is looking terrible. Why is it not? What's this about? Anyway, so, but it'll give you a little bit of a sense of what decision tree is. Tell me, Chad, if you are a complete absolute beginner, and then, we'll take things very slowly. But actually, I'll tell you what, I'm gonna do a diagram here. And this is the thing. I actually tried to hook up my iPad to this to do a whiteboard. But then I thought I do have a little, pen thing here, which actually was my first gift as a content creator. I was gifted this. How amazing is that? So I was like, okay, I might as well use it. But the thing is, I'm still not too used to this kind of pads. The iPad is much easier. Right? I got a Galaxy tablet, so a brand new one. So I'm probably gonna unbox that and then use that maybe. But for now, this is actually quite good. I gotta get used to it. So let me try this. Whiteboard. Again, just trying different things, right? And I think TLDR is the extension. No. So I'm using, it didn't work. I'm using an extension in my VS Code, which is, which for some reason it's not installed. I thought it was. Oh, there it is. TLDraw. TLDR. Yeah. Which is to do whiteboards on Visual Studio Code. If you don't know it, I recommend it. Super cool, right? I know why. Right. The reason why is because I started this project from my WSL. So I'm on Windows, but I'm using the WSL Ubuntu for it. And if you're using Visual Studio Code, You may know this, may not know this, especially if you don't use Windows, maybe you don't know this. But you know, the best how is the Linux subsystem. And I do have a Mac, but then I create my content on this one because I got beast of a desktop and it's Windows. And yeah, so I installed it on the Windows side of things, but I didn't install the extension on the Linux side of things. So you need to do that. So now if I go back there, wonder if this works. Yes, it works. Okay, we got a whiteboard. Yes, I am the right region of the IDE. Although, yes, granted, maybe it would have been better with a Mac. Which I do have. I have a souped up Mac. But I like this desktop a lot. It's been with me for a few years now, actually. But I built it myself. So I built it like way ahead of the of time, you know. So for its time, and it still holds up. That's the advantage of building your own PC. So I probably should replace this one off. Right, decision tree. So what's a decision tree? Let's see first. I can actually... I need to get used to this. So this is going to be terrible, right, to begin with. But let's put here. Oh, okay. So that's not good. I'm going to try to get good at this. Real time. So the... Oh my god. This looks like kindergarten. Ah! I cannot do a straight line. Wait. Oh my god. I don't know why, but like when you're actually... It's so weird the way the brain works. Just because it's a pad with no screen on it, actually, like the iPad or my Galaxy Tab, it just... The level of difficulty increases like 100-fold. So weird. Even if I wasn't terribly... Well, I suppose I am looking at it more than I realize than when I'm doing this. But yeah, without like the preview, the brain doesn't connect. So difficult. Right. Oh, I know. Like, I can do this. Look. Would that be more pleasing for your eyes? There you go. Decision tree. So, what is a decision tree? Oh my god, I need to... What extension is this? Ah, yeah, super cool, right? It's... Oh my god, I need to sneeze. I forgot to do the disclaimer as well. I've got full-on hay fever. Oh, the only way I control it today is by... I literally got all windows closed, no matter how hot it is. It's a sauna in here in my house, but when I keep all windows closed, isolate myself, I can survive. And I love cinema, so that's one of my tricks to survive through spring and summer. I go to the cinema a lot, although I did that in January anyway. So TL Draw, that's the extension. Install that, and then what you do is create a file. I've got too many. Create a file with TLDR extension, and then boom. It's just like Draw.io. It just kind of comes up. Brilliant, right? And you can do it with the mouse anyway. You don't need a pad, but if you got like this, then it's amazing. I'm gonna try to connect my Galaxy Tab. It's just that the iPad is a bit of a nightmare, and I actually managed to connect the iPad, so I could use it. It's all set up to use, but I thought, hey, why not? I'm gonna try it this way, because then I got my VS Code. It's all one screen, not multiple things, you know. Makes life easy. So yeah, that's tip for the day. Extension VS Code extension tip. TL Draw. Okay, decision tree. So the first, let's do some terminology. So the first thing is, how does it look like? Well, not like that. Okay, how does it look like? It looks, as you expect, like a decision tree. Oh my god, check me out mastering this. So it's gonna have a few nodes like this. So that's the first terminology. And and then it doesn't need to be, you know, that neat. It could be like this. And then, yeah, so the first terminology is, let's go this, node, right? Oh my god, I am mastering this pad. I kid you not. I just connected this like 40 minutes before this started, and then I gave it a go. I said, yeah, I'll try it. I don't have much love for rehearsing. I go with the wind. I love taking risks. Now, this one at the top is the parent node. You know what? This will do just fine. I am getting very used to this. But you know what's something cool about this? I'll show you if you're gonna try this extension as well. Is that I can do this. Look, you can go text, draw a quick text box, and then I can type parent node. And it does the text all cute like that, as if I wrote it. Isn't that cool? Right. So let's do the same for this, because I have forgotten about this. Right, so node. The only thing is that then I have to type with the pen in like this. So I may make more typos than usual. It's a tree of decisions. Indeed. It is, but you will be surprised how much science and math there is behind this. But that's, stuff that you can get into later. The important thing is to understand the basics, and that's absolutely what it is, a tree of decisions. And that is the point. The point of decision tree is to emulate, like a lot of artificial intelligence, because that's the point, emulate how we make decisions, how we think, right? It's raining, it's not raining. Do I take an umbrella? Do I not take an umbrella? Easy decision. It's not raining. I'm not taking an umbrella. Or you live in England, and then you know that, not an easy decision, because it could be completely sunny, 40 degrees right now, and in the next 10 minutes turn and become snow. Which is actually not a bad analogy. Maybe something that I can use later on. Anyway, so terminology. We got a parent node, sometimes, by the way, also called... Okay, I was nailing this. Sometimes also called the root node. You choose how you want to call it. This, unsurprisingly enough, why does it keep going? The only thing that I don't like is that it keeps going back to this. I'm gonna look up why it keeps going back to selection every time. This is a child node, as you would expect. Now, any guesses for how you call these little things here? These arrows. Well, you call them branches. Okay, why did I do that? So you call these ones branches, okay? And there is an important distinction here between this one, this node, and this node. Can you guess what it is? What's different about this and about this? What's the difference? Anybody guess? Hello, Rat Panda here. Does this has to do with binary search trees? It can do. Binary search is, well, yeah, it's another thing. But yeah, binary search is very much focused on search, right? And in a way, it's very deterministic, right? So you split the binary search. I'm trying to find number 10. Is it bigger than 3? Is it larger than 3? Then go here. Is it larger than 5? Go here. Is it larger than 9? Go here. 10 is here, right? So yes, it is related, but decision trees are much more, are deeper, I would risk saying, because they are an algorithm to make decisions in general. And what they're really good for, by the way, which I haven't mentioned yet, is two things: classification and regression. They're very good for those things. You cannot use a binary search tree for regression, right? It's to search, it's to find a result, not to classify something, or not to find a number, for something, which is what regression is. But good, very good question. And yes, they both are trees. But decision tree, the way that these branch out is all mathematically driven, algorithmically driven, and the whole point of machine learning is that it will work things out for you. We're gonna get to it. Or at least I'm gonna try to get to it today before it's 5 a.m. But I can see like there's a lot for us to talk about here. So this is probably gonna span multiple live streams anyway. But let me know in the chat if you wanna talk about. No worries. Thank you for asking, Rat Panda here. Rat Panda _ here to be more precise. But if you want to jump straight into some kind of concept or question, by all means, yes, keep on asking, keep on bringing those questions. Love it. Okay, so we got the parent node, branches, child node. So the difference between this one and this one, as you may have guessed anyway, is that this has split. This has a split, right, into two things. This doesn't. This is the end of the tree. So this is what is called a leaf. Oh, well, a leaf is a special node, so maybe take special treatment. No, because then nobody can understand what this is. Go away. Right. Leaf. Right. So, you know, it is kind of handy that it goes back to this because I can just tidy things up. Leaf. And the leaf is the end of the tree, right? And each one of these is a level. So kind of like an array, not kind of like an array. You know, you would typically count from 0. So level 0, level 1, level 2. Okay? But it has, you know, 3 levels, this tree. And so how are you gonna do this? Or how are you gonna make this useful? So let's say ambitiously, let me see if I can actually draw a table here before I jump into code and all that. Oh, actually, let me just get it from my code. No, let's just try to draw. Let's get adventurous. So, come on, give me... Okay, cool. So let's say we got a table of data. So, oh my God, this is so pretty. Right. Well, that wasn't pretty. Can I hold shift to make it straight? Let's see. Or whatever, because usually shift. Oh, check it out. Love standard conventions. Let's make this really simple. Let's just have 3 attributes. Okay. And oh my God, I'm all over the place now. So the first attribute will be ID, right? And ID can be anything really. ID can be a number, like a database, or my God, this is pretty, right? Or it can be you know, a something like text. So what was I doing when I was doing this content here? Right. So diet, for example, dieting. So let's say that we got lettuce here, and oh, gold. Destroying my art. Okay, I can very easily adjust with the mouse. Look how beautiful this is. Loving it. So let's see that the point here that we're trying to establish is it healthy? Or better than is it healthy? Can I eat this in my diet? I don't know. And actually, this is a good point. What diet? Well, I don't know. There are many different types of diets. So it will depend on the use case. How do I make this one line? Did it just... I don't know. I'm just curious now. Oh, look. I don't know how to make this one line. Right. So can I eat this in my diet? It's what we want this decision tree to tell us. So we want to feed a bunch of data. So say a bunch of foods here. So let's say... Go faster with the mouse for now. Lettuce, cake, and let's see... yogurt. And then for each one of them, we're gonna say capture calories. We're gonna capture sugar. We're gonna capture... We could capture protein, for example. Oh, and by the way, I have friends that make fun of me, like the way I say protein. Is it funny? I keep trying to say it in different ways, but it's like protein. But apparently I put too much emphasis on the teen, protein. And it sounds like a protein, like a teenager. It was, you know, I'm all for teenagers. Let's put vitamins. I don't know, number of vitamins. So maybe it's something stupid. And then based on these things, we want the decision tree to tell us, can we include this in our diet? Because we're dieting right now. Okay, cool. So let's say we go for calories, like let's say 100 grams, right? Let's take like 100 grams as a parameter. Let's say it's about 15. A cake's about on average like 500, and yogurt it's something more like 10, like 100. I think like let's put 100, make them easy for me. And then sugar, lettuce, 100 grams would be like something like probably 0.3, 0.5. I've done nutrition in the past, by the way. Trivia, I actually did a nutritionist course once, got certified, never really exerted. It was like from my own knowledge, my own project at the time. I was like, I had all these intellectual projects, and I was like, I want like a body project, physical project. That's when I got into fitness many years ago. I was like, can I have a six-pack now? And then just starting like the whole science behind it. It was all kinds of things. I didn't achieve a six-pack. I got a four-pack, but that will do. Right, so 0.3 cake. Let's say, how much sugar on average? I was looking this up. For 100 grams of like about 48. And then 12. Okay. And then vitamins was so let's say 3 for lettuce. Then we have 1 for cake. Believe it or not, there is a lot of vitamin A in this kind of sugary things. Not a lot, actually. I said a lot. Did I say a lot? Not a lot. But actually, it's more like 2. But there is some vitamin A, so you're not completely ruining yourself. Right. Okay, cool. So we got this data, and now what I want to do is have this decision tree help me make decisions. The first thing that it needs to do is decide what is going to go in this parent node. What is it that is going to start that decision tree? So each one of these things in machine learning is called a feature, right? I'm going to keep it everything from the beginning because the first time we talk about decision trees here. So, I'm going to assume we are discovering this from scratch. So each one of these is called a feature. Arrow. That's probably like a proper arrow in the shapes thing. I'm going to, for now, really, is it gonna stay like that? Oh, okay. I think it's because I'm nailing this now. It's because of how I draw the text box. So I have to draw like always. Okay, got it. Feature. So this is called a feature, right? And the prediction. So say the result, which for us will be, can I eat this in my diet? True or false? Is called the is this? It is. Okay, it is an error. I don't even need to go into shape or anything like that. Okay, it's called the target. My God, right? The target, or you could say the result to make simple, right? Or the category, or the classification, the class, right? For instance, as well. So you could call this many names, but ultimately, this is our target. Our target is, once the decision tree arrives at these leaf nodes, these have to say yes or no, right? So that's what we want to achieve in the end. I'm going to draw this. Yes, no. Yes, no. Oh, actually not that one, because that one is still. So this is the decision. How is it going to do that? The first thing it needs to decide is, where do I start? How am I going to know which one is the best place to start? Is sugar the best place to start? Is calories the best place to start? Vitamins? What matters the most in this decision? So the only way you can tell is by us telling it as a human what these results are, right? For a set, for a number of data points, so that it can know, you can learn, from what we give it to the algorithm, what is right, what is wrong. Then it can run all this math to determine which one of these things matter the most. Say it ends up deciding that sugar is the most important thing to decide whether I'm going to recommend you to include this in your diet or not. Then you can give values that it hasn't seen before, and it will run through that tree. It will run through this decision tree, and then output, hopefully, good results, right? So it's a whole journey how you get to that. But in its most simple way, the first thing it's going to do is determine which one of these are the best place to start, like I said. To do that, we need to initially, or now I need to extend this table, whatever, give the results. So I'm going to say 1 and 0, okay? 1 is true, 0 is false, cake, 0, yogurt, 1. So I'm telling the algorithm this. If it's lettuce, it's okay to include in the diet. If it's cake, nope. If it's yogurt, it's okay. And now it's gonna go, okay, almost reverse engineering. It's gonna go, if this is okay, let me look at the amount of sugar it has. Let me look at the amount of calories. Let me look at the amount of vitamins and see if I can find a pattern here. What else is okay? Okay, this is okay. So let me look at the calories and you see how this goes. And then it's gonna try to find a pattern. Why is this not okay? Well, this is like over 40 times more the amount of sugar. There's something to this, you know? And this is what the algorithm is gonna do, derive those patterns. So say it finds at first that sugar is really where we should start. And it goes, you know what? Sugar, wow, that is not sugar, that is sugar. I'm gonna put shoe, right? Let's say sugar, if sugar is say less than equal, let's say 20, then if it's less than equal than 20, we're still not sure. So we're gonna check, what about the calories? So go here. If it's greater than 20, then, oh, actually, sorry. Let's make this 10. And I'll tell you why in a second. 10. There you go. So if it's greater than or equal 10, then we're gonna check the calories. If the calories are greater than or equal 100, you can see where I'm going with this maybe, then yes, include in your diet. Otherwise, no, right? Because here, like I said, I'm keeping this simple for now so you understand. This will be yogurt, right? This will be cake. And yogurt is cool. That can be in our diet. Cake cannot. But, you know, yogurt does have more sugar than lettuce, and yet it's okay. So what we find here is the thresholds, right? And that's pretty much at the heart of the algorithm. What are the thresholds? Ah, that was terrible. Never do that again. How do I change color? Here, right? There you go. What are the thresholds that we need to calculate to arrive at the answers? My God. You know what? I'm not doing as bad as I thought I would. With the pad, that is. Which will arrive us at the answers. Okay? So, so this is at the heart of it. And everything that we do in decision trees is about how do we know this is the best thing to do, right? That this is the best condition and not the other. And there are a few ways that this happens. So the first one is by trying to figure out here which one of these BOTs are the most important ones, and at what point they become the most important ones in the next level of the tree. So the algorithms that are determining this are what we call greedy algorithms. Okay? Why are they greedy? Because can you imagine how complex this would be if we started going, okay, if I do sugar like this, if I do calories like this, if I do this, if I do that, if I do that, if I do that, do I arrive at the right result? Now, let's change. What if sugar was actually 11? What if it was 12? What if it was... It will be too many permutations, too many things, right? Depending on the amount of data you have, depending on the amount of features you have, so this columns the data values, this will go on forever. So decision trees don't do that. Decision trees use greedy algorithms, which means what is the next thing that is best, not all the way down. So when it's starting to walk the tree, it goes, okay, I'm gonna start with sugar, because it will do a calculation based on these figures. Remember, kind of reverse engineering. Based on the information you gave me, let me try to find a pattern here. I think this looks good. I'm gonna try this out. That's the training process of machine learning, right? Training means trying things out, seeing if the result was good. No, do it again. No, do it again. No, do it again. With different things, different parameters, different thresholds here in the case of decision trees, different hyperparameters and parameters that will keep changing the result until you're happy that that satisfies your use case. And that is why it takes so much processing. I told you early on that machine learning takes a lot of processing, and the more you discover, the more you understand why. That is why. It's very iterative, the process, right, of discovering these things. And what it's going to do with the greedy algorithms that it uses to calculate the next thing is it's going to go, if I do sugar is less than equal 10, then if I test that against all the other things on the data set, what does it arrive at? If this was the decision right here on level 2, the next thing that comes here will be the decision. What is the best one? That's the one I'm gonna take. Whichever one gives me the least error in prediction. And how do I know that? Because we are giving the machine the results already, right? So it can compare. It can go, okay, I tried this. Let me compare with what you told me. Nah, it's not right. I'm gonna try this. Let me compare what you told me. Yeah, it's closer, so this is better. I'm gonna try again. Okay, that's worse, so I'm gonna go back and try the one that's closer. Now I'm gonna use that one. Next, let's see what else I need to work out. This is how it's going to work. That's why it's greedy, because it's gonna go, you know what? I'm not gonna care about the rest. I'm gonna care about what comes next. I'm gonna assume that I can take it all, I can have it all just by selecting this. I'm greedy. And there are two main greedy algorithms. For terminology's sake, we can go deep into them as well another time or whatever today. I don't even know what time it is. Okay, and there are two algorithms. One's called Gini. The other one is called, entropy. However, these are like the approaches, the actual like low-level algorithms, right? So depending on when you're dealing with these things, on what level you're dealing with these things, you may not actually even have to know about them. If you use something like scikit-learn in Python, which is the library that you will use, like, for example, if you're using JavaScript, you've got JavaScript libraries, right? They abstract away a bunch of stuff. Same thing. If you use scikit-learn in Python, which is, the content I'm creating here, which I'll release eventually, maybe I'll create videos on it, but it will be on my GitHub and all that. It's a tutorial and I'll teaching about decision trees. Then scikit-learn is just a library that you install here, pip install scikit-learn, and it has a bunch of cool stuff for you to learn machine learning, but also actually do it as well. And scikit-learn will abstract these things away from you, although you will still use them if you're gonna get downgrade into the data science and machine learning. But with scikit-learn, for example, you will use two different algorithms. Where is it? Here. That abstract Gini or entropy away. So that will be cart, and might as well add here to the text box. Can I? Oh my god, I love this thing. So cart, and for entropy is this ID3. And the default, if you're using scikit-learn to do decision trees, you will use cart by default, which is a Gini approach. And you can then select, say, no, I want to use ID3. Or you can actually select random. You can use either one of, every time that it goes through this tree level, it can select a random, go, okay, how am I going to split this? I'm going to use entropy. How am I going to split this? I'm going to use Gini. You can actually do this randomly. I mean, there are reasons why you would do that, but let's not go into that. By default, rule of thumb, and most likely than not, you're going to pick one of them. So for example, picking the default, that means that every time we're going to do this split, we're going to decide on it based on Gini, which is an approach, an algorithm, which then is encapsulated by another algorithm called CART, right? And how these things work is a whole other level. But so pretty much what I want you to take from this level here of learning about decision trees is that decision trees mimic the brain process that we have of making decisions. It's just that you may have many different factors, right, on which each level of the decision depends on. And that is the same in your brain. It's just that you don't realize because we think really fast, right? So I just mentioned, am I going to take an umbrella or not? Is it raining? I will. It's not raining. Wait, there's more. Like I said, I live in a country where the weather is really unstable, so maybe I will. But I also live in a country where there is wind gushes that make umbrellas fly off, and I just waste money and time taking umbrellas. So actually, no, I'm going to take a hoodie instead. So no, I'm not going to take an umbrella. I'm just going to wear the hoodie and screw it, right? Maybe a waterproof raincoat, whatever. So even our brain has these nuances, right? Different criterias, and decision trees are no different. The only difference is that for machine learning, for machines, they have to work these things out mathematically. And the way they do that is based on numbers. So you gotta give a set of data. So here I got 3. You typically, with machine learning, we have thousands or more, way more, right? Why? Because what you want is like here we got, I don't know, like maybe like say 10,000 would be great, you know, maybe more, maybe like 1 million sets. Fantastic. Why? Because you're learning patterns from the data. That's what machine learning is all about. How do you learn patterns? By having lots and lots and lots and lots of examples. So this is the same with foundation models, right? Foundation models have vast amounts of general knowledge, like us humans. So I've never encountered a bear in my life. If I encounter a bear, I think, well, I don't know if I know what is the right thing to do, but I have an idea of the things that I can try doing because of my general knowledge. I know how far I can jump. I know how fast I can run. I know a bear runs faster than me, most likely. I know they can climb trees, so that's probably not an option. You start making choices, right? Because of your general knowledge. But surely it will help if I had the specific knowledge of what to do if I encounter a bear. Like I've seen some YouTubes of people going, you know, make yourself tall, whatever it is. So, you know, specific knowledge, great. But by having general knowledge, you can make general decisions. But the more data you have, the more knowledge you have, the better decisions they are. As long as it's not garbage. Because if it's bad decisions that you are putting into this model, then the machine is going to be fooled by it and go, okay, I guess this is the universal truth. So I'm going to use that as assumptions. And then I'm going to say, sure, if a bear comes towards you, then go towards it. Because somehow I got in there some movie scripts about some Marvel movie in the data set, which made the machine assume that humans can fly and have lasers. And it's going to say, just shoot a laser off your hand. It's like, uh-oh. But whose fault is that? The human, because I put garbage in. And that is a concept of bias, right? Bias. So the data sets that we put in can come with bias. And with decision trees, you have to be very careful that you don't introduce that bias in the tree. So it's one of the points about decision tree is that, like I said in the beginning, and like I told you here on a high level, it will pick the features by doing mathematical calculations that seem to draw a pattern on creating these decisions, right? But if I put some bias in here and I go, you know what? I think cake is okay. It's fine. You know why? Because I know how to bake this cake, which is 0 sugar, 0 cal, whatever. And it's a cake. but you know, I'm gonna put 1. And besides, it's fine even if the cake has this many calories, because I go to the gym every day, so I'm gonna put it in my diet. So I'm gonna flag it as 1, and now I'm gonna feed it to the machine learning. I didn't even think about it. Now we have a bias in the data set, because this is a very specific rule. Maybe I don't care about it because I burn calories like crazy, but that's not the truth for this diet. You know, let's say if it's a keto diet, right, and low carb diet. So what I've done is introduce bias on it, and that's when you have to be very careful with your data, because the decision tree will take that bias and then create all these steps, all these things for you without you doing any data cleaning, because it's gonna assume that what you're giving is true. To be fair, this is true for most things, right? Most, not just machine learning, but data projects. The famous saying, which I think I already said a few times here as well, but how do I make this huge? Okay, I'll just give it the length. Garbage in should be in red, really. Garbage out. There you go. Can I actually change the color after the fact? Let's see. That would be awesome if I can. Oh my god, I can! That's awesome. In fact, I can even change the size. Look. XL. There you go. Garbage in, garbage out. So you have to be very careful with this, right? Now, this may all sound not only perhaps a bit vague, but also obvious. I remember when I started my with this whole, you know, machine learning thing and data science thing, that I thought, like, this sounds really stupid and obvious. Like, I used to design games, make games, and you know, once I did like this decision game, like a text adventure thing. And if you think of text adventures, if you know them, that's what they are, right? I go like, okay, so it's a game that I'm actually resurrecting for demos and stuff. Maybe it's a real project, we'll see. But you know, you go like, okay, my character started, oh my god, okay. Not that small, yeah, okay. So my character started in a bar, and then then aliens came, and then, you know, the decision was go outside, whatever, don't even. And then, actually, I'm doing this all wrong, isn't it? Because if I actually do my proper game design, then it would be like, okay, it was in a bar, then decision, go outside, then yes, then see UFO, or no, ask for the bill, whatever it is. You get the point. Anyway, so yes, it is much like that. It's in a way, it sounds obvious, but let me show you. Oh, that's with NumPy, right? So when you're doing decision trees, they are like an algorithm like any other. I'm using scikit-learn here, the library, machine learning library. You may have heard of it. If you haven't, it's a great machine learning library, especially for you to get started on, and it does all kinds of things for you. One of the things that it does, which is what I'm using my content here, is that it has built-in data sets. Really cool, right? I'll probably explore this in the next stream in more detail. Maybe we'll go through the whole code, but so I can import, like, it's got a few of them. I think I put here already. Yeah, there you go. So it's got a few of them here that you can choose from, few databases, and you can just call these methods like low digits, low diabetes, low iris, which is what I'm calling, and it will have the data set all done for you, and you can return as pandas data frame, and then you can use it to train stuff. And if you look here, you see that I'm importing a decision tree classifier. So that's the algorithm I'm using. Again, scikit gives me that. And then skipping around a little bit here, I'm gonna just instantiate that. And then what I'm gonna do to train this model is I'm gonna give my training set and of the values that I have for all this stuff, and then I'm gonna give the prediction, the result, right, for all those values in this training set. So what does that mean? That means my X here training set is these values: 15, 0.3, 3 for lettuce, for cake, 500, 48, 100. So this is my X set here. There you see my X training set. And Y, by convention, it's my target. So this will be all these values: 1, 0, 1. This was a 0 before. So now what it's going to do is do all these calculations, this reverse engineering, create this tree in a few different ways using Gini and greedy algorithm. So it's gonna go, okay, thank you for the data. First, I'm gonna try sugar. And it's gonna pick that through an algorithm as well, right? Yes. M. But don't worry about what ASM is. We can explore another time. But it's gonna use an algorithm to then pick which one is I'm gonna start from, and then it's gonna go, okay, I'm gonna try sugar less than equal 10. Didn't work. I'm gonna try sugar less than equal 50. Didn't work. Because every time it's gonna be comparing to the Y result, which is this one, right? Until it gets to the end of the tree and it's all done and dandy and beautiful. And this is what this does. So if I run, actually, let me run all the outputs. I'm gonna run all. And then what I want to get to, I'm gonna ignore all that, is this. So here's a graph that I put out about the importance of the attributes. And I want to show you this because this is one of the huge advantages of decision trees, right? Oh, hi, Anna. Don't know if you're still here with us. Sorry I missed your message on the chat, but unfortunately because of Twitch rules, I can only show the Twitch chat on my screen. So I need to train myself to keep an eye on everything. What's the name of the app? Which app, Anna? If you're still around, please let me know what app, because I missed your question. Why I was talking about something probably, and now I missed the context. If you mean the library, scikit-learn. If you mean the VS extension, the VS Code extension, maybe that's when you asked, when Damien asked as well, then that was TL Draw. TL Draw. Right here, actually, I'm still got it on the screen. There you go, that one. Okay, right. So much to explain. It definitely will take a few iterations, which is a little bit of a, I guess, joke on recurrent neural networks and all that. But anyway, so what are we looking at here? What I'm looking at is I plotted here on this graph what this decision tree that scikit-learn output for me that I can use now to try to predict if things are good for my diet or not, based on all the data that I gave it, which was the attribute that was the most important that he found. How did he find that? He found that through various experimentations. My data set here is the iris data set. Sorry, I didn't say that. So going back to the top, as I was saying, scikit-learn has various built-in data sets that you can use. I'm using the iris data set. The iris data set is a database of flowers. It's actually a very classic one, a very classic example from, I forgot when, but something ridiculous like 1936, I think, something like that. It's 1930s anyway. So anyway, it classifies flowers, the iris flowers, into what kind of irises they are, what kind of species, right? And it's already all loaded up for us. That's I want to visualize it. Oh, whatever. I can visualize it here if you want. Right. So if I put data set here, then we can have a look at it. There you go. So actually, a bit neater. So this is the data set, right? So it's giving me a bunch of sepal length. I have no idea. Oh, the game, Rihanna. So the game, which I completely forgot about, haven't I? Jeez, we should go back to the game. Is Wild True Learn. Let me see. If I go to the menu, then you see. I can always load the level again. Anyway, there you go. Wild True Learn. This one. So you can get it on Steam. Can you? I think only on Steam actually. I play on my Steam Deck as well. So you go on Steam and Steam Deck. Well, because Steam Deck is an extension of Steam. I don't know if they got it anywhere else actually. I think it is more like a PC game. Maybe on the Mac? Don't know. But maybe you can check it out. Yeah, Wild True Learn. Really cool game. Not giving it enough time because I decided to do a proper decision tree lesson here. Do let me know if you guys want to go back to the game. Just tell me on the chat. Let's go back to the game. More than happy to do that. And we'll go back maybe for one more level so I can at least know what's coming in the next one. But we can also talk about decision trees along the way in the next episodes as well anyway. Because like I said, there's a lot. It seems simple, and it can be. Like in the realm of the data science, it is like one of the simplest ones. But there's a lot. Anyway, so what I'm doing here is visualizing the data set that scikit-learn has given me out of the box. So it's a data set that has data about flowers. I have no idea what these things mean. That's a good thing because when you're learning data science, I mean, you can be familiar with the data set, but also not knowing what these things are helps me not introduce bias into this data set. Not that I prepared the data set anyway, but I would be, data cleaning or changing things or making decisions as I try to perfect my model for my use case. So actually the fact that I don't even know what these things are helps me not introducing bias, which is an incidental point anyway. But most importantly, you don't need to be an expert in the data set that you're dealing with to be able to do data science. And that's what I want to illustrate as well. So I have no idea what sepal is. Petal, I have a bit of an idea. But if you tell me what is the most important thing for you to classify flowers, I've no idea. And guess what? Because I was working on this content, I learned it through a decision tree. So this is something that decision trees can help you answer. I cannot answer that question with the foundation, but well, maybe I can ask it because it's got this general knowledge. I can ask it directly, say, Claude, what is the most important feature in a flower that I should use in my blah, 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 right? Sure. But that's a different level. We're dealing here now with the science and I don't know. And guess what? Because I'm using a decision tree, I can answer that question. So if I had a problem, somebody had come to me with the requirements, can you tell me what is the most important thing for you to classify a flower? Guess what? I could build a decision tree to do that. That would be a very geeky, nerdy way of doing it. But you can. Is data cleaning as a data scientist different from data cleaning as a data engineer? No. Okay, yes and no. So it is not in the sense that the things that you do are the same. Deduping, outliers, well, all garbage, data, which then will take more expertise, right? Because if somebody puts their petal size 1 billion, yeah, I don't know, maybe it's possible. I don't know much about flowers, but if I'm an expert in that or I understand my data set, then I know that's garbage. Something went wrong there, get it out. Or just like the cake example from earlier, right? No, that's rubbish. Cakes. Well, if I'm from before 2000s, I may say that's rubbish. Cakes cannot have 0 calories. Into 2024, they can. So even what was garbage once may not be garbage later. But, all kinds of levels and things there, of course. But so the process and the things that for you to watch out for are the same, but the purpose why you're doing it as a data engineer or as a data scientist is different. Because, for example, if you're doing data engineering for observability, for monitoring, yeah, your purpose is to get, even if it is a graph on the screen, something very deterministic, something very, is the server down? Is the server up? How much percent was the server down yesterday? 28% of the time. Whoa, that's a lot for our production server. Or maybe not, if you got a massive cluster of 1,000 servers. That was just one of them. Great. Um, but you know what I mean? It's very deterministic. Whereas as a data scientist, it's a lot of ambiguity. And it surprises people that actually you don't want to have 100% accuracy with your model, because that means you outfit it, that your model is outfitted, which is a whole other topic. But outfitting in general just means that your model is not good at predictions. It's really good as at getting right what you told is right, what you said was right. So in my example here, so it can come up with a decision tree that at the end, for every one of these, outputs exactly right. Lettuce 1, cake 0, yogurt 1. I got it. This is perfect. If you run an accuracy score on this, it's going to be 100%. Accuracy score being one of the things, one of the metrics that you gauge, you know, is this algorithm good or not in data science. 100%. Oh, fantastic. I solve all problems in the world. Well, guess what? Now, if I just give it the numbers here, the features, but not the results, the target, it may actually come up with rubbish, because who said that you provided it with every single possible permutation example in the world? You probably didn't. And as we know, like in the real world, there are many different things that have anomalies, right? Things that happen, like the cake, which is now 0 calories in 2024, which is unexpected for somebody in the 90s. So yeah, so you don't actually want that deterministic thing that you do as a data engineer if you're doing things with the purpose of cleaning up data, you know, for this kind of activities. So yeah, it's different, I guess, but a lot of overlaps for sure. So the question that I answered here really was, what is the thing that is most important to determine irises anyway? Petal width. Petal width apparently is the most deterministic feature. So it will heavily feature in our tree. Shall we find out? So here, what I'm doing, don't worry about the code. We can dive into it in the future, or you can get it on my GitHub once I publish. This is still not published. This is literally my first commit. I just started doing this afternoon. Then what I'm doing here is just actually rendering the tree. Let's see it visually. There it is. Look how beautiful it is. It's beautiful. I can imagine that that data can be structurally valid, but statistically nonsensical. That's a really good way to put it, because it is all about probability and statistics. That's what machine learning is all about. This Gini thing and this, get out. This Gini thing, this entropy thing, probability, right? And statistics. The ASM as well, statistics, probability. Everything comes down to it, right? So this is the tree. Look at that. So let's have a quick look at the tree. So what did he come up with? By the way he came up with this is by iterating many times. Where did that happen? Did you see me doing that? No, that happened right here with this one method call. How beautiful is that, right? So this is the beauty of using Python for data science. If you ever heard that data scientists are all about Python, whatever, but you know, it just sounds like fanboys and thing. No, this is why. Because with Python, you got libraries such as scikit-learn, which allows you to train a model by just calling .fit. Give it the X train data. Remember, this is this data here. And give it the Y data. Remember, that's the target. That's a convention, by the way. Y is the target. X is the values. And it will do it for you. And what has it done for us? Well, it has gone over this data set. Well, by the way, this is one I just made up, right? As I was talking about stuff. The one I use is the iris one. That's one we're talking about. It went over this data set multiple times. Many times. Trying different things out. Trying these algorithms. and going, I'm going to try to split using the Gini algorithm, the cart algorithm. And it went, okay, this is looking good. Oh no, this is not looking good. Try again. This is looking good. Oh, this is not looking. There is something better. Try again. If I put it on random, oh, now try entropy. So I'm going to try ID3, which is the algorithm in scikit-learn that you can use that uses entropy, and then does a few more things, with it. Oh, okay, this is looking good. That's how it does it. And how I know it doesn't, it has done that. So you can see here in samples. So it tried 100 samples and used Gini. Remember I told you by default uses Gini as an algorithm to determine the split, right? So you can think of a splitting algorithm. So it tried 100 times and then came up with the Gini score of 0.665, which it determined this is as best as it's gonna get without me trying too hard. Trying too hard goes back to greedy algorithm. So as you can see, it didn't try all the samples because this data set, go up. I think yes, this data set has 150 columns. 150 rows and 5 columns, right? So 150 data points, 150 samples. But it just tried 100 before giving up and going, that's good enough. That's greedy algorithm, right? That's what greedy algorithm means. It didn't have to try everything. I'm happy with this. I don't think we're gonna do any better. Move on. So it tried it 100 times with 100 different items, and then it got the Gini score that it thought this is as best a Gini score as I'm gonna get with this stuff. Then it came up with the values for each one of the categories. So we had 3 categories in this data set, 3 types of viruses. Of course, in the real world, we have probably thousands. I don't know. I'm no flower expert, but pretty sure there's more than 3 types of viruses probably. But in this case, we got 3. So this is kind of like the score for how it scored on each one of them. And then it decided that for now, I'm going to assume the class is Setosa. This is the name of the iris, right? There's Setosa, versicolor, and I don't know what's the other one? Virginica. There you go. So for now, I'm thinking this is Setosa. But let's see. It determined that the best way to split this tree for us is by going petal width if it's less than or equals 0.8. If it is a Setosa for sure. We reach a leaf node. So we arrive at a decision that fast, right? And it tried this 35 times. The Gini was 0. Fantastic, because the lower the Gini, the better. So he was like, damn, I'm sure about this. So this is a Setosa, end of question, end of everything. Now, if it's false, okay, this is greater than 0.8, we have more stuff to check. And again, he went through all the data points. He did it 65 times before he was satisfied. And he went, okay, 0.497 is as best as this is gonna get without me blowing my brains over it. I'm talking about the machine here. For now, I'm thinking now this is a versicolor. I don't think it's a Setosa anymore. But let's test. Is it less than, and you're getting the gist of this now, right? So if it's less than, it's still petal width. If it's less than this, we go here. If it's not, we go there, and then we keep testing, right? So if it is, then we're gonna go, okay, we're gonna test on petal length now, not width. So as you can see, it's not as simple as just the one thing that it keeps testing on. It keeps changing the different features, right? So these, it keeps changing between the different features to arrive at, oh my God, at this target here, right? Which is a Y value, to see if it's 0. 0 here is the one type of iris, 1 another, 2 another, right? Again, 0 based. And there are names for them, like the Setosa. It's just that I'm not displaying them in this table here. I'm just displaying them 0, 1, 2 for the categories. And it's gonna keep testing things until it arrives at leaf nodes. So if we go through all this, we arrive at Virginica. Otherwise, it's versicolor. Otherwise, Virginica. Otherwise, versicolor. Otherwise, Virginica. Otherwise, setosa. And that's a decision tree on a high level. So I hope this makes sense. And like I said, there is a lot more to this that we can dive deep into, but also I don't want to go all in. However, the one thing I haven't mentioned, which is maybe where I should start if I'm going to do a review next time, is that when this kind of machine learning, when you are telling the machine the answers, this is when you are having machines learn from us as humans, right? We are the teacher. When you do this, effectively what you're doing is, oh my God, this was completely pointless. I cannot even read this now. Look how cool this is. Wee. I love this. Awesome. So yeah, so when you do that, Excel and yellow, because it's my favorite color in case you haven't noticed from my branding. Supervised. Look how cute. Learning. This is what we're doing. So that's what a decision tree is all about. Supervised learning. And supervised learning algorithms, surprise, surprise, are good. Why do I keep scrolling? In two things. Classification. Oh, I'm gonna get that wrong. Any reps to the next line. And regression. And guess what? What are decision trees good at? Classification, regression. Classification is what we just seen, right? Classification is this. Is this a setosa iris? Is this a versicolor iris? Is this Virginica iris? Is this an umbrella day? Is this a no umbrella day? Is this a cat? Is this a dog like in the game now? Well, the game's not talking about dogs, but is this a cat or not in that picture? That's classification, right? Now regression is when you arrive at a number, right? You want a number out of it, probability. So instead of me saying, is this an umbrella day or is this a non-umbrella day? That's classification. I'm going to say, what is the probability that is going to rain? Is it 80%? Is it 65.84%? That's regression, when we want to arrive at a number, right? And yeah, decision trees can do that too. The thing is that instead of the result, the target here, the Y being a name like setosa, versicolor, whatever, it will be the number. 80%, 70%, 60%. And then the way it's done, like the algorithm used to do the splits, and the way it approaches that is what changes with regression. And with classification, the default even, right, is Gini. So most of the time you use Gini, which is why it's the default. So this is really good for classification. Entropy is, that's horrible. That's because I got, can I undo please? Thank you. Right. So entropy is that it's really good for regression. Small, there it is. Small, yeah, classification and regression. Now, it's not quite like that. It's not like you only use entropy for regression. You only use Gini for class. I'm just kind of trying to give you direction, signs, right? Because I know, at least for myself, when I come across something new, and somebody says there's this and there's that, the first thing that comes to my mind is, when do I use one, when do I use another? I need something to put this in buckets, in brackets, so I feel like I can at least make a difference between them. So, you know, this is just like a, how'd you call? It's not signpost, I think is what I'm trying to say. So yeah, Gini is really good for classification, and entropy really good for regression, but you can use, you know, either one for both. You can even use both in both. Like say, can you use random? Every time you come here on the split, you go, I'm going to use Ginny to try to work this out. I'm going to use entropy now. So that's possible with whatever you're doing, regression classification. But yeah, what I wanted to say is it is supervised learning, which is when you are actually telling the machine the answers. If we weren't telling the machine the answers, guess what? This is too easy now. What is it called? Unsupervised learning. It's not in Excel, but it's fine. Because we're not doing unsupervised learning today. So that's good. That's not in Excel. There you go. It's going to stay like that. Unsupervised learning. In fact, it shouldn't have exclamation marks because it's not the topic today. And unsupervised learning is when you would just give these values here. Oh, look at that. Neat. But you don't give these values here. Okay, not neat. But you don't give these values here. So it only has the data points. It doesn't have the results. And funny enough, we do that when testing the data, right? Because how did it know that these things were right? To recap, because we told it, right? Because I gave it here. And by the way, don't worry if this seems like a lot. It's the kind of thing that needs to be revisited many times. And we will revisit it many times. And, you know, you can ask questions. There's no dumb question here whatsoever. I promise you. You could even ask, what is Python? Absolutely fine. What is a variable? What is a sum? I don't care. No dumb questions here. So, how I told the answers was by giving my data points, my X and my Y, which they are separate. That's why, you know, we even draw them separately here. They are separate things, right? My data points, my predictions, my results. So I give them both. And when it's doing the iterations, it's taking those data points, going fluke, putting through those mathematical algorithms, and then using this set to go, was I right? Was I right? Was I right? But as you may notice here, I split my data set. I'm not giving the full data set, I split. Why? Because I want to have a bit of my data set where it doesn't know the answer. We have the answer, but I'm not telling the machine the answer because, we want to test the machine. Much like any interview test that developers hate. We need to test that the machine knows what it's doing, that it's technically correct. So what we do eventually, have I got there? No, I haven't. Okay. Oh no, I've done, I put it up here. I don't know why. I've done a few of them. For example, I'm going to run an accuracy score. I want to say, what is the score of accuracy for this tree that it has output? Because if it's no good, I'm going to tune it. And how am I going to tune it? With parameters and with hyperparameters. So the way I'm going to, okay, one thing at a time. So I'm going to tune it with parameters and hyperparameters to keep changing that tree until I'm happy, right? But how am I going to know? I need to test it first if I'm happy with it. So what's the first thing I can do to try to test it? Accuracy score, which sounds like the end all and be all of everything, but surprise, shock horror, is actually the worst one. In data science, accuracy score is not really the best thing to test on. But you got the accuracy score there. Scikit-learn has a function for it, so I don't even need to do my own thing. But what I'm going to do is I'm going to give that test data set, so those points that I set aside, the predictions, and then I'm going to give against the predictions that he made, right? So I'm going to say, look, I didn't tell you about this, but I have more data with the right answers. And now I want you to score yourself to see how well you did with these new ones that you didn't factor in your learning, right? So they're new items as far as the decision tree that he created is concerned. He's never seen those before. But we got the result. We know if they're right or wrong. So I can test against it. Now this is what you would do with unsupervised learning. Have things like my test set here that you're not telling the machine the results, except that with unsupervised learning, that is the data that you would use to train. Whereas with supervised learning, it's just the trick that you use to test the model with, right? It's just data that you're gonna give to test the model. And once you're happy, then you're gonna join those up actually with supervised learning, and then you're gonna train the model on the full data set anyway. Which makes it fully supervised. Supervised? Yes, supervised. So yeah, I think that's quite a lot anyway. Look, if you have any questions, I'm happy to answer them on my DMs. You can follow me anywhere as codingmatheus. I have not played much of the game today, so having done this kind of basis on decision trees, maybe next time I'll give a bit of a review to begin with of this high level, which will be more concise. And maybe I even have a bit of the decision tree content out anyway to support this. So you guys can go and read after or before, whatever. And then we'll play a bit more of the game, continue on with the levels and all that. Or I can take it all back, start from the beginning again. It's up to you guys. That's the beauty of doing it live. You guys tell me on the chat and I'll follow. And then, of course, we keep on doing more and more. And Wild True Learn is not the only game. By the way, like I said, there are many other games. So even if you have a request for a game that you like, that's educational, that's cool, that will get us learning, that is geeky enough, then let me know. Damien, I can't thank you enough for being here. @Panda_ here. Thank you so much for hanging around here with me for all this time. Thank you, and please, like I said, do let me know feedback and all that, questions at any time, and we'll probably continue with decision trees next time because it's a lot. Thank you guys. It's a bit late here in the UK, so hopefully you're going to bed. Have a good night, sleep well, and see you on the next one. Bye everyone. Thank you so much. See you next time. Bye.